Hello? Can you hear me, guys? Probably, yeah? Okay, cool. So before most of you actually depart for machine learning workshop downstairs, I'm going to try to introduce you to this faster they can start. Thanks for everyone for coming. Thanks for everyone who came here through stairs. I want to make it worth for you. So I'll be talking about Flutter, and more importantly, I will be talking why I'm talking about Flutter. So I'm a mobile developer. I'm leading the Android community of practice. This is my community of practice tab. We've started 5 years ago, and it was me and James on the left. And now that's it. So it's a nice team of young people who try to push the engineering forward. They never settle for what is there. And because of it, we always look what's next thing we have to learn and why. So we observe a lot of technologies coming in and going, and they have a life cycle, like Android has a life cycle. They have a life cycle too. So if you get a zoom out, like to 1700, and you say, do you want to build something which can actually speak by itself, or transfer the voice over the long distance, you would be burned on a stake for witchcraft. And then actually in 1950s, you say you can have a actually computer in a pocket. Probably a couple of years later, you see it on a Star Trek. Actually, they had the iPads there, and it was magic. Still, it was not possible to know. Back then, computers were big rooms, this size roughly, to do very simple computations. And now there is some magic ahead, and we still think about magic. What we're looking for, we're looking about this, the cool stuff. This is something which is not here, it's not yet, but it's very close and it can start anytime now. And there's a guy who started to look at these things, but he was looking from the perspective of companies, because he noticed that the companies which build the technology and make it famous, make it big, they absolutely fail in the next iteration. The new technology comes in and it destroys the old one, and this was his theory. And why this happens? Because if you have a market, you have more resources, you have more power, why can you be destroyed by a startup? Actually, you can very easily. And I will show you the example. So, 150 years ago or 100 years ago, you could cross Atlantic one of these. It would take you 5 days to do it. Cool. 5 days. That's cool. But then the guys came and built this. And if I show this picture to the bosses of Cunard who were running the ships through the ocean, they would be laughing at me. To be honest, one of the guys who built this thing said, this thing will never fly from London to Paris. This is what one of the Wright Brothers said. And now we have it. 50 years, 2 world conflicts, and we have an entire industry running on it. So it is not that easy to spot the technology. It's very easy to dismiss it. And then when you wake up, it's a bit too late. But everyone says, okay, the one technology destroys another. I beg to differ. They shift. They change. So if I now want to do the nice trip around Honolulu, probably I will take a plane to fly there and then board the ship and have a trip around port or other islands. So you see, it's not like this technology is going away and completely is thrown away. It just shifts its focus. It just starts to be elsewhere. So what is the trade of a disruptor? What is something which actually we should look at when we assess if something is worth our time? Because there is a lot of ideas, lots of technologies, and everyone is asking, what should I do next? And this is what the developers will do for all their lives. Is that, okay, what is the next thing I should learn? And the problem with this is that when a technology, when an idea appears, is very weak. There's lots of weak points. There's a lot of things which make it not usable in most of the cases. So we dismiss it. So let's see on SSDs. On the beginning, they were like, what, 8 gigs, 4 gigs? You couldn't install Windows on it. So why would I buy that? Why would I put it in my laptop if I can't run a Windows on it? Maybe you can run Linux. But inevitably, it removes some inherent problems that the previous technology has. It couldn't pass it. In case of the steamships, it was essentially the medium in which the travel occurs, which is water. You cannot travel faster in the water. That's it, as simple as that. You cannot compete with it. You have to figure out other way. And this is what was actually making plane more useful. So do the old companies die? Actually, no. There are some who survive. And one of them is Intel. And why Intel is surviving? Because initially they started with actually making memory chips. Then they jumped to processors and various processors and different technologies. What they do, they jump their stack very frequently. And when they do when the current stack is the middle of the maximum growth. So this middle point there, this is when they actually branch, they create a new department, and they start from scratch something completely new. This way, they're never caught off guard. This was actually when Andy Grove was at the helm. The moment he seized his leadership, they're caught by ARM, right? So yeah, that's one thing. So you see the technology which is not that great, but definitely removes the inheritance of the previous one. It moves the problems which were causing that some things couldn't be done in a previous one. And that's your one criteria. The second one is how simple the system is. And one of my friends from TAB, the architect Ricardo Bennett, he said, this is a question I'm giving to every candidate who is coming. Please draw me on this whiteboard the simplest architecture and simplest system. And the result is supposed to be this. This is the simplest system. It has an input, there's a system as an output. There's a minimum number of connections here. Then if I break the system, only input output has to be corrected. If I start to draw more lines around, put more dots in it, it will be more complex, it will be more difficult to fix it. So we're looking for simplicity, we're looking for things which doesn't have an inheritance in things that cannot be changed. So I'm gonna show you something which actually show this better. I hope you don't know much about rockets, because this is why I use this example. So now they look very similar, right? There's some exhaustion here going, pushing things, Newton stuff, simple. But they differ a lot. They differ a lot. What is different between them? Is the way they were built. The one on the left is built on parts which are older than me. They are actually running the engines which are derived from engines which are supposed to send Russians to the moon, right? The one on the right is built using knowledge gained by going to the moon. And the result is stunning. This is how much they cost. So you see, this is the cost of dragging the old stuff behind you. So what to do with mobile? Currently, most of the mobile is done this simple way. It's either MVP, MVC, MVVM, lots of MVXs. And this is how we've done things for the last couple of years. Now we switch slightly the model. We have a view in Android. We send something with some click to the presenter. Presenter fires the use case, which contacts the repositories. We do the stuff, and we get the feedback back. We show this to the view. Simple, nice, clean. It's called clean MVP. And then you build another one, and another one, and another one, and you start having lots of callbacks. There's a term, callback hell. Callback is becoming a very dirty word now, like singleton. You should not use singletons now, because I know that in a book, you should not use them because you cannot test them. So callback is another word which becomes very, very dirty. Inherently, all these ideas, it doesn't matter if you're a presenter, controller, or view model, what they really do, they do this. They send the information, in and out, and you never know who is right at a specific point. You don't know it. You always ask yourself, is this calling from here? Who is right now? Am I actually clicking and changing my item in a basket, or is it backend telling me that actually someone changed this basket on another device? And you have this problem with MVXs all the time. It's always the question, am I right at this point? Maybe there's a conflict. Should I settle who is right? And this is the biggest challenge on this. And what it actually causes your architecture start to break, and you have lots of problems with it when the use cases become more complex. So people around the globe started to think, well, okay, how we can make it simpler? How can it be so stupid that I can explain to a rubber duck? And it is, okay, we can do a lot of bad things here, so let's limit what we can do and put some principles instead. And they did. So there was a very interesting talk by Lee Byron on the immutable user interface. It's on YouTube. And he talks essentially about giving up this mutable layers of things going around, embrace immutability and embrace the flags. So this means the one place that you can change the things and control how the change occurs. This way you will make simpler to everyone understand what is going with the app, because there will be only one place to look at when a change occurs. So what is Redux or Flux? I don't know which term is actually more accurate. I think the the Flux is the pattern and the Redux is implementation. But yeah, everyone says some different things. So let's say we have a store. What store does? It has a state. It also says something called reducer, which I will just speak a bit. So what we do, we have an action. Action will carry the data and the intent, what you want to do. I want to add something to the basket. I want to log out. I can say which screen, with which parameter, and whatsoever. Then the store will ask the reducer to produce a new state. And this production of the new state is instant. It's not delayed, it's not asynchronous, it's simple function which does that. And this will trigger the response on a view which is binded to this state. And then the view can actually fire another action, and other actors can do the actions, but we know that what we're looking at, what we're binding to is always right. It's never outdated. I don't have to think, is this event came from here, from there? No, this is the truth. The truth is my state. I don't have to do extra logic around who was actually causing the change of the state. So there is a number of mobile solutions, right? So when we started, it was iOS and Android, cool, native apps, high performance, also high price to do that, because different stacks, different needs, different designs, testing, all onto it. So people start to think, okay, how can we run single code on both? So let's put it in a web view. There's a lot of problem with it. The main problem is that web view is not equal to web view. There are different web views on every device, and depending which device you will get, you're going to have different implementation, and you have a lot of very funny tests that you, very funny bugs that you cannot easily test or spot before they actually happen on this device. So then people said, okay, how can we have a single code, but actually try to show the native widgets? The concept is pretty cool. Yeah, you have a one code which then transforms itself into the widgets, into the views on Android, into some views on iOS, and they render. It's called React Native. But there was a problem with it. The problem was the bridge. The problem was that transferring this, what's supposed to be done on the JavaScript, because React Native uses JavaScript, to what is rendered was the slowest part. So this bridge was always the bottleneck. And all the strategies about how to write a good React Native apps is about how to cross the bridge. So yeah, so what can we do with that? What if we simply move the bridge far enough that it won't matter? What if we take control of all the drawing? Everything will be ours. And this is what a Flutter is. So it started a couple of years ago, probably you've heard of, maybe not. It was this very spooky, no one heard Sky project, which was then shut down, It wasn't shut down. It was just renamed. And it was started by Chrome people. And they were simply looking at how to make a better web. This was the goal. It wasn't build a cross-platform tool for mobile, whatever. No, they were just looking, how can we make the HTML better and CSS better? Of course, they were using Dart because they wrote Dart, and the Dart is running on Chrome, so it was easier for them to do it. We're talking about times where there's no TypeScript and things like that. And what they figured out that if we wrap this whole thing and run it, we can send entire pictures of what the UI of the application should be and send it to the OpenGL or Vulkan. There was no Vulkan back then, but there was OpenGL. And plenty of devices have OpenGL. Think about it. We're not talking now about mobile phones. We're talking about televisions. We're talking about things like PlayStation. Why not? Why make it a platform that can actually cross anywhere it wants? And what is really cool that it's, this is the first question I get from any, PO, product owner coming to me. Okay, Swav, on this project, what version support we will have? And I have to look at the data. I have to check, okay, 12% on Android 4.4. Oh my God, that will be rough. To convince them to actually drop it because I don't like 4.4. And here you don't depend on it because you render everything by yourself. You will be sending everything as your application. And currently it's beta. Beta is very stable. It has a preview of Dart 2, but it's a preview. A lot of things are very, very early there, but you can actually try. But there are 4, I would say, main take-up from Flutter, which are very important. So one, that they simplify the pipeline. This is what I mentioned. The second is they simplified how the view is traversed. They simplified the DOM itself, so writing is easier, and the reload time. This is my favorite one. So quickly. So this is React Native, right? So you have your virtual DOM stating this is the widget I want to have. Then you have an engine which actually compares, okay, what is on the other side of the bridge, what I have here, what I'm supposed to modify. And then you send this through the bridge to the platform widgets, you render, and this renders on some frame on the device. Cool. So let's move it. And the Flutter guys move it. But then they realize that actually compare update and platform widgets are not necessary because we own everything. So let's make it simple. And they did. So this is how it actually Flutter renders. It takes whole control of a UI on a screen. You don't see material design widget. It's a widget created by Flutter which looks like material design. It's not Cupertino toolbar on the iPhone. No, it's a widget that looks like it. And this means that I can deploy the app and it looks exactly the same on iPhone 4. If I tell my iOS friends at Tab, please make me app for iPhone 4, they say, you crazy? I forgot how to deploy on this because they don't support it for I don't know how many years already. So this is the power of it. It's completely independent. But also the power is that it gives the power to the designers because we control everything, which is much easier to do the tricks. We're always pushing away because our SDK can't do it. It's sprint, 2 sprints to make this fancy widget. No longer. Why? Because you have access to all these things. It's on your side. So simplifying the layout. This is Android layout, if you haven't seen one before. You see the relative layout is layout which allows you to do things like align something to the parent of the start, on the back, on the center, and so on. Cool. The problem I have with that every widget inside has to determine where it's going to sit. It says align parent start, true. Center vertical, true. And the next one, and 60 of them in a line. And then someone says, Swav, for this layout, I need to have a linear layout. Actually, it doesn't use these attributes. It has a different attribute. I have to edit all of those to make it change. This is direct violation of a single responsibility principle. This thing, this text view does two things: where it's supposed to be and how it's supposed to look. It should focus on how it looks. Let's do something else, actually job where it's supposed to be. That will be the real composition. This is why Flutter differentiates it and says the parent knows where to put that child, and the child knows what is my size and how I'm supposed to paint myself. And that's it. This means you do the text widget, which only is about printing, formatting, breaking lines, all the stuff. And the parent actually figures out where it's supposed to be, because the same mechanics will apply to the image, to the button, to any other widget. So why duplicate the code? Why don't make it simple? So this is how the Flutter layout looks like. So you see that one widget which says, okay, put me anything in the center. So it only cares about not how it renders itself, it cares about how to position the children. And the only child it has is a column, which has two widgets, text and an icon. And this is the result below. Simple as that. Flutter also uses very simple constraints. They help determine what the size of the widget might be. So you determine 4 values, minimum and maximum. But what is really cool about it, that apart from the fact that it's very expressive, is that actually this situation is called constraint, tight constraint. And what it does, it allows to speed up the rendering of the widget. Why? Because when we detect that one layout is tight, then we know that the tree below cannot change, because tree below will be tight. This means this entire tree we can reuse when we redraw it again. So hey, we actually we saved a couple of milliseconds on redraw, which is pretty cool. That's one of the things. So this is actually the part which is the part of the immutability thing, is that when you have the big objects, and for example, in Java, you were avoiding immutable objects in Android. Why? Because garbage collection was slow, and you could see actually on the device when you're actually cleaning up your memory when you scroll, which was making iOS guys laugh at us a lot. So what we've started to do, we started to use mutable objects, reuse them before we garbage collect them. And then we found that actually on the other languages, the immutability is fine, like Dart, like JavaScript. And we can reuse them and parse them in a simple manner. When we detect that something is immutable from here, that we can actually use it in a new object, which is a mutation of entire tree, but this subtree is completely copied over from the old one. Saves a lot of time. In Flutter, everything is a widget. How many of you develop Android apps before? Yeah, so Android has a life cycle, right? The life cycle, it starts, it resumes, it does stuff, it pauses, it destroys, you never know when. You have to learn this hard way, and it's a problem that Flutter has 2 main classes, stateless widget and stateful widgets. They are both immutable. The only difference is that the stateful has a mutable state, and you simply build them. You will build these widgets, and you will send them to the framework, and framework will decide what to render, what has changed, what haven't. It's not your job, do it anymore. On Android, I have to find a widget called user in an existing layout tree, and then set the attribute on it, text, for what I want to set, then wait for actually draw to happen. Here, I'm building entire layout each time and just sending it to the framework. And later, OK, framework, figure out what happened. What really changed? So this is a simple app that everyone shows when actually does the demo with a Flutter. So this is this animation I'm going to run. So yeah, normal reload time on Android, on my project currently I'm doing is 2.5 minutes. That's coffee time every time. Here it's slightly faster. It's measured in milliseconds. So I'm changing stuff. The app is running. The state is persistent. I'm clicking the buttons. I see the stuff, and I press reload. My code actually has changed. So you have pressed now, not pushed. And I can do it again. And I'm building an app as I see it. That's massive improvement. I don't have to log into my app every time I'm checking if my basket is actually displaying correctly in my scenario in Android, which I have to do when I'm running specific scenario. Here, I'm just having a state all the time, 380 milliseconds, 500, 600, 800. That's the usual change. Now, I've deleted one of the buttons. I don't know if you noticed what really happened. Now I'm adding, please look at the button. It doesn't just appear there. It animates it, it comes in. Why? Because the framework itself, what it does when I please the hardware is just run this build again. Which means, okay, the change has stayed, the state has changed, which means I have to figure out what's the diff. The diff is, okay, I have a now fab button, so let's animate as it actually appears. Because this is how this button should appear. This is how this framework, this is not extra functionality added to Android like Instant Run. It's built within it. Why it's built within it? Because years of development on Android and iOS and all other platforms led to the conclusion that this is worth it to have it in a framework, not have it outside. I've done some testing on a hot reload because there were questions there, okay, how does it scale up when I build a big app? And no one was actually able to tell me how does it scale because no one tested. So I wrote a simple code generator which created 250 packages with 80 unique widgets each. I mean, 80 unique classes each, and pulled it into one app. And I tried to see actually how it scales. So what I found is actually the reload time only goes up if you do the massive change. If you change half of your widgets, half of your packages, then the change will be longer. They will go to 3 seconds or something like that. I'm talking about 3 seconds, not 3 minutes. That's what Android does. So you see the difference. This is one of these impediments that you can see that was actually causing that some things on Android can't be done easily. Here they can be done. And what are the benefits? It's easier to build things because there are no extra plugin elements or build tools elements to support it. It's perfect for TDD. If you do the small changes, as Uncle Ben asked you, this means that you can actually do this very easily. On my project currently, I cannot physically do it. It's impossible because I will waste too much time on reload. Another learning from all the frameworks that we have, and Android learned this the hard way, initially having the AND builds, now having the Gradle builds, is to have a framework already with the build tools. They have to be there, and they have to be owned because by the project itself, because if there are dependents, we start to slide into this other, more expensive rocket, right? And the libraries, they have to be somewhere. There has to be a place to get them from, because we want to develop fast. We want to use QR code scanner or something else. They have to be there. So there is. It also comes with a tool which actually helps you figure out what's wrong with your build and with your tools. So it's not Stack Overflow only. It's actually your tool telling you, and if you submit the bugs, please do this and send this as well. This is going to help actually figure out what was happening very easily. You'll see, okay, this is the version I'm running. We're addressing this. We're not addressing. So you will see this happening. Now, more things. So channels. What are channels? So there is the stuff when you want to talk to the other parts of the device than actually UI itself, right? You want to talk to Bluetooth, networking and stuff. And in some cases, you have to use extensions. Let's say I want to use Bluetooth. I want to have a QR code capability in my app. So then you have to write the native code. This is the part when you see the symbiosis between the old engineering, the native engineering, and the Flutter. This is this cruiser scenario. Yeah, you still need to know how to write it for Android. You need to know how to write it for iOS or ask someone to do it. And this is organized in this way that You write it once and you publish it as an extension. You don't write it again and again in your each app from scratch. Reload for free, fine. Tools, we saw. Pub, we've seen. And it's open source. You see everything. When you compile, you will get entire stuff inside your APK. It will be 6.8 megabytes high. That's pretty good. Not as good as I want it. And because if I go to 4.6, I can do instant app. I can't do instant app with it. So probably I will talk to Rupert later how we can do it. Actually, instant app can accept higher level. And the open source is very important, which means that you can check documentation, the code, directly as it is. The way the SDK works is that it's not like there is a big update coming, you press the button like Android, so it updates your SDK, downloads libraries. No, it's a Git repo. You run the Flutter upgrade, and it just checks out the current state of the framework, and your each app will be built with a newest version of the framework. But because it's packaged with everything in it, it's supposed to be there, it's completely independent. It's not going to break. Your device will wither and die in some cardboard locker, whatever. It's going to still run on it because it's just compiled in this way. And all the people who tried it, they're coming with the same conclusion. It's just fun. And I might say that this is one of the things which distinguish Flutter. It's just easy to start, easy to dig in, understand the concept, and you just build on top of it, and you see how much you can do you couldn't do before. So I wanted to try to prove it because everyone say, okay, these guys tried it, so they may try to justify why they tried it. So this is the exercise. So I invited some 20-something people to the workshop, and yeah, 100% of them never used Dart. 50% of them never code a line of code, ever. There are people from our resourcing, recruitment, managers, everyone. And just say, guys, do something. Now, can you tell me which one was done by the team, done by developers only? Any guess? Yeah, Myanmar art. Yeah, Myanmar. It looks the ugliest, but yeah. that was, yeah. And fun is a feature here. And it's not just for kicks. Imagine this. If you want to start it, you want to the new framework, you want to try to make it as easy to pick up as possible. The learning should be instant. Oh, I know that. I captured that. And this is why it's so important. So that's it. The live coding will be later. So if you want to try. If you want to prep for a live coding, here are the things that actually you can help you start. So Flutter.io, it's a very comprehensive documentation. It's amazingly good. And I hear this from React Native guys who are like in direct competition. They compare and say, OK, this is really straightforward to learn from there. Because it's maintained and it's in very good shape. So start it, prepare for it, and we'll have fun. Any questions? Because we have a lot of time. Yes?
How does it compare to Xamarin, for example, or to React Native? Because those will be its competitors.
Yeah. So let me go back to the slide. Oh, this one has lots of clicking. Yeah. So Xamarin is almost on the same, it's like on a border. So it doesn't use the React patterns, but it uses the widgets like React Native, right? React Native essentially renders the widgets of this framework. If I use some strange, I think LG was always trying to do different styles of widgets on an SDK. If you run the app, which is written in React Native, and you run on this LG device with fancy theme, it's gonna render this fancy theme layouts. and you cannot stop it, because this is how this device is compiled. This is how the widget looks like there. With Flutter, it will gonna look exactly as on your screen, because you're gonna render it, not the device. And this is the main difference between Xamarin and React Native. But the React Native also have this reactive pattern, so it's definitely a step forward. It's just not that far.
So it's basically taking the rendering out from the device and giving it to the app itself? Yeah.
Think about this as a Unity 3D for mobile apps. Yeah? You build a game, you put it on a phone, it runs on everything, right? And the same thing. You write an app, you put it on everything. Done. Yeah? Cool. No more? Please ask some questions, because then I can write blogs about it. No? Thank you.